Greetings all, and welcome back to Math in Anger. This is episode 6, and in this episode, we are going to be looking at less than nothing. How do we actually think about it? Because it is not a natural thing to think about. I mean, how do you think about something that isn't? How do you think about something that does not exist? So it's a bit of a problem for many of us, and what I'm going to aim to give you here is how to think about this stuff, how to think about this business, right? But before I do that, I need to address this. What does this symbol mean when you see it like this, right? So when I write this, when I write that picture for you, what it actually means is 5 more than nothing. And the reason we don't do this is because it's kind of natural to understand that this picture means that you have more than something. So that is implied. What that means is it is it is understood that you are typically talking about more than nothing. But when you talk about less than nothing, then you've got to be very, very clear about it. And that is when we do this. And that means you have 5 less than nothing. This picture, it means the value you have written here, that you have less than nothing of it. Okay? So that means I have 1 less than nothing. That means I have 2 less than nothing. This means I have 413 less than nothing. Right? So let's take a look at how we think about less than nothing. There are a couple of ways. All of them are valid, but you need to be sure that the one you use, you're using correctly. Right? So you end up in an exam and you get asked which is greater, -1 or -2. And then you have this picture in your head where when you go, the higher you stack something, the more positive it becomes. The word positive literally means more than nothing. All right. And then with this, when you start digging holes here, that's when you move into the minus direction, the negative direction, the less than nothing direction. And the word negative literally means less than nothing. Okay? So here's the mistake we make. Because what we do is we go and we measure this, and we measure this, and we say, oh, hold on, this is greater than that, this is bigger than that. Okay, cool. So 2 is greater than 1. And yeah, that's perfectly correct. 100% correct. But now we're going to say, okay, let's measure this then and measure this. Okay, so -2 must be greater than -1. And I've done this experiment. I've actually drawn this picture and I've asked people which is greater. And almost without fail, they go and do this. -1 is less than -2. And then they get into an exam and they get one of these. And nobody ever explains to them why. And the problem comes in that they measured from 0. They measured from their 0 point. If you do that, you are going to get this wrong. Here's how you do it the right way. With this stacks and holes idea, you measure from the bottom. Let me do that in another color. You measure from somewhere below, as far below as you like, but it has to be below, right? And you go and you measure this distance, this height. And now you can see that, hold on a second, 1 is higher than 2. And you know, 2 is higher than 1. And now you go and sit in your exam and you're like, oh, hold on a second, that must mean that -1 is greater than -2. And then you get one of these. Right? When you're using the stacks and holes idea, make sure to measure from the bottom. But there is a thing we use in math, and it's really important. Honestly, the sooner you get used to using this idea, the easier you make your life with respect to mathematics, because it is in all the textbooks and it is everywhere. Everywhere. And that is this thing, the number line. And the way this works is you have your 0 point, the point at which you have nothing, this here. Where with the stacks and holes idea, you had your 0 point being the ground. With this, the 0 point is in the middle. And here again, the further right you move, the further you move into the positive direction, the plus direction, and the further left you move, the further you move in the negative direction, the minus direction. But here again, a lot of us go and make this mistake. We measure from there to there, and from there to there, and then we go and measure from there to there, and from there to there, and we're like, oh, hold on, 2 is greater than 1. That means that -2 is greater than 1, and then you get one of those again, and nobody explains why. When using the number line, the point you measure from is not 0. Let me just get rid of this. The point you measure from is way over here somewhere on your left hand side. And then you go and measure this. And now it becomes very clear. -2 is less than -1, which is less than 1, which is less than 2. And then you get into your exam and you go and write -2 is less than -1, and you get one of these. Or you go and write -1 is greater than -2, and you get one of these. Right? When using the number line idea, measure from your left hand side and think about these distances. That is how you get that right. Okay. But I'd like to bring all of this back to the balance scale. and show you how all of this business works in the balance scale. So let's do this again. There's the balance scale. Now, it's kind of difficult to think about nothing when you're thinking about weight. But what if I told you that underneath each of these trays, I'm going to build tiny little shelves, and inside each shelf, I'm going to put a weight, and all of those weights are going to weigh exactly the same, and I'm going to put an infinite amount of them down here. Now, I can't draw an infinite amount of weights, but I can resemble them like that. And just like the heaps and holes idea where I told you there was a 0 point, and just like the number line idea where I told you there was a 0 point, that on your balance scale is the 0 point. Now let me demonstrate something. If I take weights away on the left hand side here, I'm basically saying I have 3 less than nothing. I have -3 here, and -3 is less than 0. Do you see that? Let's take a look at the actual example that I did here with -1 and -2. So if I have -2 on this side and I have -1 on this side, which one is greater? Which one is less? You see that because there's only one weight missing here, it is heavier than this side because there are 2 weights missing. All right? Now there's another thing I'd like to show with respect to the balance scale. Let's do this. Listen very carefully to what I'm about to say. 1, 2, 3, 4, 5 more than nothing, with the addition of 1, 2, 3, 4, 5 less than nothing, is in balance with 0. Look at the picture. 5 more than nothing with the addition of 5 less than nothing is in balance with 0. +5 with the addition of -5 is in balance with 0. What I just said there, you're going to see some light bulbs going on when we get to addition and subtraction. For now, this, what I've demonstrated here in episode 6, is how you think about things that are less than nothing. Okay? I hope you learned something. This was Math in Anger, episode 6. I will see you in the next one. Ciao.